In this video, we're going to be focusing on a very important concept, which is rationalizing the denominator. You will get questions in the examination in number systems that will ask you to rationalize the denominator. More importantly, this idea that you'll be learning is going to help you not just in this class, but in higher classes too, where you'll be solving questions for which the solution would require you to rationalize the denominator as a part of getting the answer to that question. We are doing 4 questions, 3 in this video and 1 in a separate video. We'll start with a very easy question and slowly increase the level of difficulty as we move from A to C. Let's start with the first one. We're trying to rationalize the denominator of 2 by root 3 minus 1. How do we go about it? Any question that asks you to rationalize the denominator, what we'll be doing is we'll be multiplying and dividing the expression, in this case 2 by root 3 minus 1, by the conjugate of the denominator. What is the conjugate of root 3 minus 1? The conjugate of root 3 minus 1 is a root 3 plus 1. So we're going to be multiplying and dividing this 2 by root 3 minus 1 with a conjugate, which is root 3 plus 1. We'll multiply by root 3 plus 1 and we'll also divide it by root 3 plus 1. So the value of this fraction 2 by root 3 minus 1 stays intact. So what happens to the numerator of this combined expression? It's going to be 2 times of root 3 plus 1. What does the denominator resemble? It resembles an x minus y into x plus y, which is nothing but x square minus y square. So x square for us is root 3 square minus y square is a 1 square. Numerator stays intact at 2 into root 3 plus 1 divided by denominator root 3 square is a 3 and 1 square is a 1. So denominator of this expression 3 minus 1 is going to be equal to a 2. Numerator is 2 times of root 3 plus 1. Cancel the 2 in the numerator and denominator. The final answer is equal to root 3 plus 1. So this actually is having a denominator of 1, which is a rational number. So you've rationalized the denominator of 2 by root 3 minus 1, where this root 3 was an irrational component. Quickly recap this in a printed form. We're going to be multiplying and dividing this expression 2 by root 3 minus 1 by the conjugate of the denominator, which in this case happens to be root 3 plus 1. So this is the expression that we have, root 3 plus 1 multiplied and divided to this term. Numerator of this combined expression is 2 times of root 3 plus 1. Denominators of the form x square minus y square, which is root 3 square minus 1 square. So denominator becomes 3 minus 1, which is equal to a 2. The 2 in the numerator gets cancelled with the 2 in the denominator to leave us with root 3 plus 1. So on to the second one, which is a little bit more difficult because both these components in the denominator are irrational. Process is exactly the same. We're going to be multiplying and dividing this expression with the conjugate of the denominator. Conjugate of root 12 minus root 5 is a root 12 plus root 5. So that's what we're going to be doing. We're going to be multiplying this expression 7 divided by root 12 minus root 5 with a conjugate, which is root 12 plus root 5. We're going to be dividing it by root 12 plus root 5. So the value of the fraction stays intact. Numerator of this product is going to be equal to 7 into root 12 plus root 5. Denominator resembles the form x minus y into x plus y, which is x square minus y square. X square is root 12 square and y square is root 5 square. So what we have is 7 times of root 12 plus root 5. The numerator stays intact. We're not doing anything to it. Denominator 12 square, root 12 square is a 12 and root 5 square is a 5. So denominator 12 minus 5 is a 7. The numerator is 7 times of root 12 plus root 5. 7 gets cancelled with 7. So final answer is root 12 plus root 5. Again, look at the denominator. The denominator in this case is a 1. We have rationalized the denominator. 1 is a rational number. Recap it in a printed form. We multiplied and divided it by the conjugate of the denominator, which happens to be root 12 plus root 5. So the numerator of the product is 7 times of root 12 plus root 5. Denominators of the form x square minus y square, which is root 12 square minus root 5 square. Denominator becomes 12 minus 5, which is equal to 7. Numerator stays as 7 into root 12 plus root 5. Cancel the 7 in the numerator and denominator. Final answer is root 12 plus root 5. The third in this video, which is rationalizing the denominator of 1 by 8 plus 3 root 5. Exactly the same thing. The conjugate and of this 8 plus root 3 root 5 is an 8 minus 3 root 5. We're going to be multiplying and dividing this expression by the conjugate. So 1 by 8 plus 3 root 5 is multiplied and divided by the conjugate of the denominator, which is 8 minus 3 root 5. So the value of the expression remains intact. The numerator of the product is 8 minus 3 root 5, which is very simple, divided by, how does the denominator look? It looks like an a plus b into a minus b, which is a square, 8 square, minus 3 root 5 square. This part is the more interesting one in this entire thing. Numerator is 8 minus 3 root 5, no change there, divided by 8 square is a 64, minus 3 root 5 the whole square. So we need to square 3 and we need to square root 5. 3 square is a 9 and root 5 square is a 5. So final answer is 8 minus 3 root 5 divided by 64 minus 45, which is equal to 19. Quickly recap this in a printed form. You're going to be multiplying and dividing it by the conjugate of the denominator, which is 8 minus 3 root 5. Numerator therefore becomes 8 minus 3 root 5 divided by denominator is a square minus b square. A is an 8, so 8 square, minus b is an interesting term, which is 3 root 5 square. The denominator is 8 square 64 minus 3 root 5. 3 square is a 9, root 5 square is a 5. 9 into 5 is equal to 45. Final answer is 8 minus 3 root 5 divided by 19.